Let's discuss the question number 33 from test 2. It's from machine design. Okay, so basically a riveted system is given. So bracket is mounted on the wall, is connected to the wall. Connected to the wall by means of 8 rivets, which are A, B, then C, D, E, F. Okay, let me put this slightly below. G, H. A, B, C, D, E, F, and then G, H. Okay, and the load is applied like this. So this, what is asked is which is the most, which rivets will have more stress. So it basically boils down to finding out which rivets will have more load, or which rivets carry more load, because that rivet only will have more stress. Okay, so how we break this problem into uh, and this is an eccentric load. When you compare, this is the CG of the rivet system and this is an eccentric load. So let me just break this eccentric load into a direct shear load. The direct shear load plus the secondary load, which is the moment E, and E is the distance between the CG of the rivet system and the load application line. So this is the direct load and this is the secondary moment load. So this will produce equal shear stress, shear load, equal shear load basically. So it will be basically P by 8 this way. The effect of this load P on each of the rivet will be producing P by 8, and the effect of this movement actually would be producing perpendicular forces, and these forces, basically each of these forces, F1, F2, all these forces F1, F2 till F8 are perpendicular to the line joining the center of CZ, and also each of these forces are proportional to their the lengths, these lengths L1, L2, L3. So these values, the magnitudes of each of these forces are proportional to the lengths. Okay, so these are, so this is how the direction will be. Okay, so you can see that once you join all these lines from the center of the rivet, each of the rivet to the center of the CG of the rivets, you'll find out that this L1, L2 and these extreme lines joining A, B, H and G are more. So the secondary load magnitude wise will be more on A, B, H and G. Now let's combine this direct load plus secondary load. So you can see that, so the thing is that F1, F2, well, let's call FA, FB, FH and FG are more than rest of the loads. Okay, so now if you take these four rivets, that is A, B, H, G, and now we combine this direct shear load which is equal in all the rivets. You will see that on A, on rivet A, the vector addition would be P by 8 plus F1. Remember this FA, FB, FH, FG are all same because these lengths are same from the CG. L1, L2, let's say L3, L4. These lengths are same. L1, L2, L3, L4 are all same. So these loads are also same. So let's consider A, the load is like this. B, it is like this. Because all these secondary loads are same on A, B, H, G. So let me denote all them with F, and this is on B. So we need to consider A, B, H, G only because the secondary loads are maximum only on these loads. So you see that when you do the vector addition, so obviously B and H, these forces are in the same line, so that the resultant will be more on this direction, whereas these may cancel out. The F will produce a vertical component which is in opposite direction to P by 8, and it will cancel out. So ultimately B and H are the heavily loaded rivets. The option is D.